Okay guys, so today we're going to talk about parametric differentiation. So when we're doing parametric differentiation, you're going to have an expression for the x-coordinate and an expression for the y-coordinate. So for example, x equals 1 plus 4 sine t, and y equals 2 cosine t. The parameter is the variable that both of these expressions have in common. So here, my parameter is t. So this can also be written as 1 plus 4 sine t, comma 2 cosine of t. Okay, so how are we going to differentiate? In this example, we'll have x equals t squared and y equals 5 minus 2t. So the first thing you're going to do is find both derivatives. In terms of t. So the derivative of x in terms of t is 2t. The derivative of y in terms of t is negative 2. You're going to flip dx over dt to make dt over dx, which is 1 over 2t. To find the derivative of y in terms of x, we multiply the derivative of t over x times derivative of y over t. So take both derivatives, flip the x, and then multiply. Negative 2 times 1 over 2t, and therefore my derivative is negative 1 over t. So let's find the equation of the tangent at t equals 2. So the equation of the derivative is negative 1 over t. That means my slope is negative 1/2. In order to find what the x and y coordinates are, we're going to plug t back into both of our original expressions. So x was t squared, or 2 squared, so x equals 4. Y is 5 minus 2t, so we have 5 minus 2 times 2, 5 minus 4 gives you 1. So the slope is negative 1/2, and it goes through the point 4, 1. So I'll use point slope form. Y minus 1 equals negative 1/2 times x minus 4. Distribute and move the 1 to the other side. So your answer is y equals negative 1/2 x plus 3. Our next example is going to involve trig functions. X equals 1 plus 2 sine squared theta, and y equals 4 tan theta. We're given the restrictions that theta is between pi over 2 and 3 pi over 2. Remember, when we do calculus, we're always working in radians. So that means it's going to be in quadrant 2 and quadrant 3. Remember, our parameter is the variable that they both have in common. In this case, it's theta. So dy over d theta is the derivative of 4 tan theta, and that gives you 4 secant squared theta. The derivative of x in terms of theta, so remember it's 2 times sine of theta squared. Multiply by the exponent, and then times the derivative of the inside, and then times sine theta with subtracting 1, so it's just sine theta. Okay. Now this is the derivative of x, so we need to make the reciprocal. And multiply that by the derivative of y. Okay, the 4's are going to cancel, and we have secant squared theta over sine theta cosine theta. So let's rewrite the secant squared theta as 1 over cosine squared theta. And when we multiply the denominator, our derivative is 1 over sine theta cosine cubed theta. Part B, find the coordinates where the tangent is parallel to the y-axis. So the y-axis is vertical. That means my slope has to be over 0 since it's undefined. In order to find these coordinates, we set the denominator equal to 0. And then we can set each term equal to 0 to solve. Sine theta equals 0, and cosine cubed theta equals 0. Well, here if I take the cube root of both sides, it's cosine theta equals 0. Okay. So the inverse sine of 0 gives you pi. That's the only answer that's in the range pi over 2 to 3 pi over 2. The cosine of 0 would be pi over 2 or 3 pi over 2. But since it's not including those values, it's strictly less than and greater than, that is not a valid answer. So the only answer to this problem is theta equals pi.